All right, welcome back. Now here's an example where we have what? We have more variables than we have equations. Okay? So these are two planes, right? And so in this case here, we're going to get infinitely many solutions because we've got more variables, okay? Which means one of the variables is going to end up being free, okay? Unless they're parallel, which it's possible, then they represent the same plane. But again, they'd still be infinitely many solutions, okay? Okay, so anyway, let's set up the matrix. So we got 3, negative 8, 18, 15, and then we got 1, negative 3, 4, and 6. And now, let's swap these. So we have the 1 in the leading position here, so we're going to swap these two. So again, just to be to do everything right, so we're going to do row 1 swap with row 2. Okay, so now we're going to get 1, negative 3, 4, 6, and then 3, negative 8, 18, 15. Okay, now we're going to eliminate the 3. Okay, so we're going to take negative 3, row 1. So negative 3 times row 1 plus row 2. And then we're going to replace row 2. And so row 1 is going to stay the same. So that's 1, negative 3, 4, and 6. And then this is going to be 0. Right? So negative 3 plus 3 is 0. And then this is going to be 9 plus negative 8 is 1. Right? And then we're going to get negative 12 plus 18 is 6. And we get what? This is going to be negative 18 plus 15 is negative 3. So double check. So negative 3. So 1 times negative 3 is negative 3 plus 3 is 0. Negative 3 times negative 3 is 9 plus negative 8 is 1. Negative 3 times 4 is negative 12 plus 18 is 6. And then negative 3 times 6 is negative 18 plus 15 is negative 3. So that's right. Okay. So now, in this case here, notice that we've got the diagonals, right? And so again, in this case here, we've got the z values are going to end up being free. Okay? Okay, now, if we wanted to, let's go ahead and eliminate this one. Instead of doing it, so we don't have to do the substitute. Let's eliminate this one. So we're going to do we're going to do 3 times row 2. So 3 times row 2 plus row 1, right? And then replace row 1. Okay, so now what is that going to give us? Let's do that. Okay, so row 2 is going to stay the same. So that's going to be 0, 1, 6, negative 3. And then this is going to stay the same. That doesn't change. 3 times this plus this is 0. 3 times 6 is 18 plus 4 is 22. And 3 times negative 3 is negative 9, plus 6 is negative 3. So now look at this. Now that we've got it set up this way, now watch what happens. This is going to tell us that what? This is going to tell us that, or let's do this one. This is telling us that y plus 22z is equal to negative 3. And this is telling us that, or excuse me, not y, x. This is x. And this is telling us y plus 6z is equal to negative 3. Now all we have to do is just solve each one for x and y. So this is going to give us what? X is equal to negative 22z minus 3. And y is equal to negative 6z minus 3. And then, of course, z is free to be any real variable, or any real number, rather. So again, I would write the solution set. You could write it this way. The set of all ordered triples, right? X, y, z, such that x is equal to negative 22z minus 3, comma, y is equal to negative 6z minus 3, comma, and then z is any real number. Okay, but again, you could you can write it in everything in terms of z as well, right? So don't forget the other way you could write it, right? You could just write it this way: the set of all ordered triples, and it would be what? It would just be negative 22z minus 3, comma, negative 6z minus 3, comma, z, such that z is any real number. And that's it. So this is telling you where the two planes intersect. They intersect along this line, right? All of the points on this line. Or no, not this line. This plane. All right, cool.